Suppose a book has a recipe listing amounts such as 1 salt, 3 sugar, and 2 flour. You cannot use the recipe without more information. You need to know whether the number 3 represents tablespoons, teaspoons, cups, ounces, grams, or some other unit for sugar. For the measurements in the recipe to be useful, the units must be specified. Nearly every measurement is a number plus a unit. The choice of unit depends on the quantity being measured. A quantity is not the same as a measurement. A quantity is something that has magnitude, size, or amount. For example, the quantity represented by a teaspoon is volume. The teaspoon is a unit of measurement, while volume is the quantity. Units of measurement compare what is measured with a previously defined amount. Many centuries ago, people sometimes marked off distances by using the length of a foot. But people can have feet of different lengths, and different people could measure different distances between the same 2 points. Therefore, a standard length for a foot was agreed upon. It no longer mattered who made the measurement, as long as the standard measuring unit was correctly applied. First main idea. Scientists worldwide use SI measurements. Scientists have agreed on a single measurement system called the SI system. The system has 7 base units, which are shown on the table on a future slide. Each unit is defined in terms of a standard of measurement. Some standards are specific objects used for comparison. Others are amounts that do not vary and can be reproduced easily. Second main idea. Prefixes added to SI base units indicate larger or smaller quantities. The 7 base units in the SI system are listed on your screen here. All of the other SI units can be derived from these 7 units. The prefixes, which we'll go over in the future, are often added to the names of the base units to represent quantities that are much larger or much smaller than the base units. For example, the prefix kilo, which is abbreviated K, represents a factor of 10 to the third power, or 1,000. Therefore, a kilogram is 1,000 grams. Similarly, the prefix centi represents a factor of 1/100th. A centimeter is 1/100th of a meter, or 0.01 meters. Mass versus weight. As you learned earlier, mass is the measurement of a quantity of matter. The SI standard unit of mass is the kilogram, which is about the weight of a small textbook. The kilogram is the only base unit with a prefix. Mass is often confused with weight because people often express the weight of an object, in kilograms. Mass, however, is determined by comparing the mass of an object with a set of standard masses. Weight, on the other hand, is a measure of the force with which gravity pulls on matter. Weight depends on the strength of the force of gravity, while mass does not. For example, the weight of an object on the moon is about 1/6 of its weight on Earth, but the object has the same mass whether it is on the moon or on Earth. Mass is measured on instruments such as a balance, and weight is typically measured on a spring scale. Length. The standard unit for length is the meter. A distance of 1 meter is about the width of an average doorway. Longer distances are often expressed in kilometers or kilometers. Kilometers are used for highway distances in most countries other than the United States. A kilometer is about 6/10 of a mile. Third main idea. SI base units combine to form derived units. Many SI units are combinations of the 7 base units. For example, speed is measured in meters per second, which is a combination of the base units for length and time. Derived units are formed by multiplying or dividing standard units. For example, area is a derived unit formed by multiplying length times width. If both length and width are expressed in meters, then the area is expressed in meters times meters, or square meters, which is abbreviated as m to the second power. Prefixes can also be added to derived units. For example, area can be expressed in centimeters squared or millimeters squared. Some combination units are given their own names. For example, the unit of force is a combination of the units for mass, length, and time, which is represented by kilograms times meters divided by seconds squared. The name Newton, or a capital N, is given to this combination. A joule is another combination unit used to measure the quantity of energy in a system or object. A joule is a Newton times a meter. Volume. Volume is the amount of space occupied by an object. The derived SI unit of volume is cubic meters, or m to the third power. 1 cubic meter is equal to the volume of a cube whose edges are 1 meter long. Such a large unit is inconvenient for expressing the volume of materials in a chemistry laboratory. Instead, a smaller unit, the cubic centimeter, or cm to the third power, is often used. There are 100 centimeters in a meter, so a cubic meter contains 1 million cubic centimeters, based on the calculation illustrated at the bottom of your screen here. 100 centimeters times 100 centimeters times 100 centimeters is 1 million cubic centimeters. When chemists measure the volumes of liquids and gases, they often use a non-SI unit called the liter. The liter, which is represented by a capital L, is equivalent to 1 cubic decimeter. Because there are 10 centimeters in a decimeter, a cube whose sides are 1 decimeter long has a volume of 10 centimeters times 10 centimeters times 10 centimeters, or 1,000 centimeters cubed. Thus, 1 liter is also equivalent to 1,000 centimeters. Another non-SI unit used for smaller volumes is the milliliter, represented by lowercase m, capital L. There are 1,000 milliliters in 1 liter. Because there are also 1,000 cubic centimeters in 1 liter, the two units, milliliter and cubic centimeter, are actually interchangeable.
Volume is defined as the amount of space occupied by an object. The volume of a solid, like this cube, may be measured in cubic meters or cubic centimeters. The volume of a liquid is often measured in liters or milliliters. 1 milliliter is equal to 1 cubic centimeter. The volumes of irregularly shaped solids can be measured by the amount of liquid they displace. For example, this rock's volume can be measured by dropping it into the graduated cylinder and reading the new liquid level. The volume of a gas can be measured by measuring the volume of the container it is in, because a gas will expand to fill its container.
Liquids have adhesion. Water, for instance, adheres to glass. This creates a meniscus and slightly complicates the measure of the volume of liquids in a graduated cylinder. Water forms a meniscus, and the liquid curves up the sides of the graduated cylinder. To measure the volume of water in a graduated cylinder, read the value at the bottom of the meniscus. The picture shows a value of 9.5 milliliters. A smaller graduated cylinder creates more curvature in the meniscus than a larger one. Mercury forms a concave meniscus, and the liquid curves down. To measure the volume of mercury in a graduated cylinder, read the top of the meniscus.
Density. Density is the mass of a substance divided by its volume. Mathematically, density is written as shown on the screen here. The quantity m is mass, v is volume, and d is density. The SI unit for density is derived from the base units for mass and length. Since volume is length cubed, density is mass divided by length cubed. The SI unit for density is expressed as kilograms per cubic meter, or kg divided by m cubed. Density is an intensive property, which means it has a characteristic property for the substance. It does not depend on the size of the sample. If a more massive sample is taken, the volume would increase by the same proportion. Therefore, density is a property that can be used to identify substances. An object or a substance will float on a liquid if it has a density less than that of that liquid. The density of water is often used as a reference because the density is so close to 1 when expressed in grams per cubic centimeter. Mercury is a liquid that is much denser than water. Copper is a metal that has a density between those of water and mercury. Therefore, copper would float between water and mercury. Cork has a density that is much less than that of water. If a cork cylinder were added to a graduated cylinder, it would float on top of the water, which would float on top of the copper, which would float on top of the mercury.
The density of a substance is equal to the mass of the substance divided by its volume.
Fourth main idea. Conversion factors change one unit to another. A conversion factor is a ratio derived from a relationship between two different units that can be used to convert from one unit to another. For example, suppose you want to know how many quarters there are in $12. To figure out the answer, you need to know how quarters and dollars are related. There are 4 quarters in a dollar. This fact can be expressed in many ratios, such as those shown at the bottom of your screen here. Notice that each conversion factor, or ratio, equals 1. That is because the two quantities in any conversion factor are equivalent to each other. This is important because any number that is multiplied by 1 remains the same. Therefore, a measurement can be multiplied by a conversion factor equal to 1 and result in an equivalent measurement.
A conversion factor is used to convert one type of unit to another. For example, 12 eggs are 1 dozen. From this relation, we can create a conversion factor by dividing one side of the equation by the other. If we have 3 dozen eggs, we can convert this number of eggs by multiplying 3 dozen by the conversion factor 12 eggs per dozen. We find that 3 dozen is equivalent to 36 eggs. We use conversion factors to change millimeters to meters and number of moles to number of atoms.
Using conversion factors. Step 1. Identify the quantity and unit given and the unit that you want to convert into. Step 2. Use the equality that relates the two units. Set up the conversion factor that cancels the given unit and leaves the unit that you want to convert into. And step 3. Multiply the given quantity by the conversion factor. Cancel units to verify that the units left are the ones that you want for your answer. Deriving conversion factors. You can derive conversion factors if you know the relationship between the unit you have and the unit you want. For example, from the fact that the prefix deci means 1/10, you know that there is 1/10 of a meter in a decimeter. In other words, there are 10 decimeters in a meter. One conversion factor for decimeters and meters is shown on the screen right now. Dimensional analysis. Dimensional analysis is a mathematical technique that allows you to use units to solve problems involving measurements. Dimensional analysis helps you determine what conversion factor to use to solve a problem. For example, to determine the number of quarters in $12, you want the conversion factor that changes a quantity from dollars to quarters. In order to eliminate dollars, you must divide the quantity by dollars. Therefore, the correct conversion factor must have dollars in the denominator.